So, how many people remember relations and functions from last year intro? Matthew, what do you think? Anybody remember? How many people have heard of relations and functions before? Good. Did you remember anything from? No, nothing. Oh, that's not good. Okay. What's a relation exactly? Let me tell you what it is. It's basically set of order pairs. Relation is nothing more than set of order pairs. Here's an example. There you go. There's a relation. Do you guys remember, like, from maybe in elementary school, like inputs and outputs? It goes into the box, it comes out, right? That's what we're talking about, okay? It's nothing hard, okay? So that's what we're talking. By the way, so you have inputs and outputs, right? So all your inputs are your x coordinates of this order pair. All your outputs are the, guess what? If all the inputs are the x coordinates, guess y are the x, yeah, your outputs. There's a fancy name for all your inputs. For example, here 7207 is highlighted. Does anybody know what we call all these inputs or all the x coordinates of these order pairs? There's a fancy name for it. It starts with D. Yes, sir. That's correct. Very good. So it's nothing more than all the inputs. It's called domain. It sounds really hard, but it's not really. So set of the first coordinates of the order pair is called domain of the relation. We have learned these in elementary school as inputs. You guys remember? Right? Goes into a box. Out comes the outputs. Right? So if we call all the first coordinate of the order pairs as domain. By the way, let's list these domain. Oh, are we still writing down? You guys need more time? Sorry, let me pause for a second. So what if I ask you then to list all the domain? What would you write? So we write them as a set. You use the brace, okay, and you put them in as a set. Anybody know what the domains will be? Truck? No. Domain are all your inputs. These are your x coordinates. So you want to say it again? 7207. Yeah, 7207, but we don't really actually write it twice, the same note. So we just write 720. We write it only once. Okay, you don't need to write 7 twice. So when they ask you, or on the homework or test, if I ask you to list the domain, you use a set notation. You write all the x coordinates, and we usually write them in increasing order. So if you want, you could leave it as 720, but normally we write them in increasing order, 0 to 7. Okay. And we, like I said, we only write it once. Are you okay with that? Okay, if all the first coordinate or the x's or the inputs are called domain, what do we call then the second coordinate of the order pair? Yes, sir. Range is correct. Very good. You guys remember range, domain, and range? Okay. So the second coordinate is the range. And can somebody list the range? Yeah, what would you write? Tony? 0, 1, 4, 11, and you even, put them in, yes. All the outputs, again, the range. Oh, yes, I wrote down as 1401, but, you want to write in order. So if you did, then you would write 0, 1, 4, and 11. Good. So normally we would, rearrange them in increasing order. Do you guys, does this kind of remind you of stuff that you learned a long time ago? Yeah. Sometimes you may have seen these like this. Okay. Anybody need more time? Okay. Yeah. Thank you. So you guys remember like having domain or you probably seen it this way: input, output. Right? They write it as, what were our inputs? 720. Okay, 720. Right? Have you seen it like this? Right? And here are your outputs over it was. Remember this picture? 14011. 140. Right? 7 goes to, when you put in the box, you get 1 as your outputs, and then 2 you get 4, 0 you get 0, and then 7 you get 11 again. You guys remember something like this, right? Does that make sense?
Yeah.
So you could actually write them as like this order pair this way, okay, or as you might have seen it this way. So they all mean it's representing the same sort of order pairs. Does that make sense, guys? 7 1, 2 4, 0. Oh, was it 0 0? No, it wasn't 0. Oh yeah, it was 0 0. 0 0, and again lastly 7 11, right? So there are many ways to represent these order pairs. What's another way of representing these order pairs? Anybody? Instead of using these inputs and output and arrows and things like this. Yeah. A graph. Yeah, you could plot these, can't you? So now I'm not going to plot, but you know what I'm talking about, right? On a graph, x and y. So here's 0 0, 7 1, 2 3 4 5 6 7, 7 1, 2 4 be over here or something. You know what I'm talking about? 0 11. I'm not going to do 11. Okay, here's 11. 0 11. Okay, so there you go, right? No, not 0 11. Was it? It's 0 0. Oh, 7 11. 7 1 2 3 4. 7 and 11 is all the way up here. Here's 7 11, right? Right. There are many ways of doing this. This is 7 1, and so forth. This is 4 0 0. So there are many ways of representing relations. Order pairs, you could graph it. You could write it as a order pairs in the set, or this box, input and output box. Okay, you guys remember these things? Okay, good. Let's move on then. So we're not only talking about relations today, but we're talking about something called functions. Anybody know what functions are? Yeah.
Isn't it when you replace something? Like say you have 24, and then you put in a number, and then it comes out as
Right. Okay. So if you have a bunch of inputs, you put up a bunch of inputs into this box, and out comes the output. So those are called. You guys remember function rules? It tells you what to do with the inputs, and it gives you the output. So yeah, it's kind of like that. But the function is nothing more than. Anybody? Function is a special relation. So it's an order pair. It's still a set of order pairs. Now, how are these set of order pairs different? How are they so special that it's got a name and it's kind of useful? Later you'll learn why functions are useful and so forth. But anybody remember what makes these order pairs special? No. You guys don't remember? Let's see if no one? Okay, this is the key point of the day. Okay, here. A function is a relation in which each input has exactly how many outputs? No, exactly 1, not 2. Exactly 1. Function, so write this down. Function, this is the key point, is a relation in which each input has exactly 1 output. Just like 4x4s. Are 4x4, are they cars? They're not cars, 4x4? Yeah, they are. But they're a special type of a car, right? So just like that, function is a special type of, it is a relation. It's a special type of relation. It just happens that it's a relation where each input has exactly 1 output. Any question about the definition? So, what about that example we just did? Very first, you see the order pair, 7 1. Which one was it? Yeah. As a group, decide whether or not those set of order pairs of relation are what? Function or not a function? Of course, it's a relation, right? Because any set of order pair. Function is a relation. But is it a function or not a function? Go ahead. I'll give you some time. Remember these? Right? 7 1 2 4 0 0 7 11. These points, a set of order pairs. So it's a function or not a function? Okay. Raise your hand. How many people think it's a function? Raise your hand. Knowing what we just wrote down here. Function is a special relation in which Each input has exactly one output. How many people say it's a function? Oh, how many people think it's not a function? You are all correct. Those will be the derivation. How many people are not so sure? Okay. Who thinks they can explain why this is not a function? Yes, Elizabeth? 7 has 2 outputs is correct. How many outputs does 7 have? Well, it becomes 7.1 and 7.7 comma 11. You can kind of see it over here too, right? Look, how many outputs does 7 have? 7 is input, 7 gives 2 outputs. So this is not a function. What about 2? How many outputs does 2 have? 1. How many outputs does 0 have? 1, right? Does that make sense? So 7 has, so if it has more than 1 output, guess what? Not a function, okay? Any question? Yes?
When you find a function, do you like look at the full set?
Yes.
And then it will like if one of the input has another output, it is not a function.
Exactly. Look at here. Like 2 only has 1 output, right? That doesn't make the whole thing function. You have to look at every order pairs. That's important, right? In that set, you have to look at every order pair. Does that make sense, guys?
Yeah.
So now I'm going to give you some order pair relations, and you're gonna tell me whether or not we have a function or not a function. Is that okay? All right, here we go. Okay, take a look at these order pairs: 1, 3, 2, 2, 3, 1, 4, 0, negative 1, 2. So we got set of order pairs. We happen to have 4 points. Decide as a group whether or not these order pairs are function or not a function. Go ahead. Write this down. Write this down. Don't just write it down first. Okay. All right, give you time. Shouldn't take too long. How many people thumbs up for function, thumbs down for not a function? You can't put in, between. Well, put in between if you're not so sure. Okay, good. This is a function. You guys are correct. Why is this a function? Who could explain? Yes. Yeah, how many output does 1 have, guys? 1. How many outputs does 2 have? Right, 2 only goes to 2. It doesn't go to any other number. 3 has 1 output, 4 and negative 1, right? Everybody okay with this? This is a function. Are we good? Okay, what about then, try example 2b. Go ahead, everybody. Now, I have shown you the order pairs as a graph. That's okay, right? Right? There are many ways to represent these, right? Go ahead, what do you guys think? So go ahead and graph these points, plot these points on your graph. Decide as a group whether or not we have function or not a function. Go ahead, everybody, I'll give you some. Okay? So, I can change all of them to black if you want. How many people think this example 2b represents a function? Raise your hand. Function. How many people think, how many people think it's not a function? How many people think it's not a function? Raise your hand. How many people think it's a function? Raise your hand. You're right, this is a function. Because each input has exactly 1 output. By the way, did anybody realize these are the same points as example 1a? Yeah. Okay, right? So there are many ways to represent, right, order pairs. So these are the same points. Yeah, question? Oh, hold on to that thought. Very good, very good. Okay, let's go to example 3. Very good, hold on to that thought. Okay, are we ready for example 3? Again, decide as a group whether or not these order pairs 0, 4, 2, 2, 2, negative 1, 4, 1 is a function or not a function. Okay, now it's pretty easy, right? Okay, so go ahead, write it down. 0, 4, 2, 2, 2, negative 1, 4, 1. Go ahead, guys. Decide as a group. See if it's a function or not a function, okay? So, Aaron, what do you think? Is this set a function or not a function? So you don't think it's a function? Okay, how many people think it's not a function? Raise your hand. Very good, very good. It's not a function. Why not? How about Andrew? How come it's not a function?
Because the input is 2 and 2 has 2 different outputs.
Yes, 2 has 2 different outputs. Is correct. So I could actually graph this for you. If I were to graph it, right? Don't you get these points? Okay. So yeah, it's not a function because 2 has 2 outputs. By the way, do you guys like, so there are 2 ways, many different ways, but for these, there are 2 ways of representing these points. Do you guys like the set of order pairs or the graph? Which one do you guys like better? How many people like graph? Raise your hand. How many people like graph better? Oh, how many people like the order pairs better? Really? Really? Okay, so that's interesting. So take a look at the 2 graphs. It turns out, write this down, guys. Turns out, we're going to get to your point in a minute. Turns out there is an easy way to see if a relation is a function. First, you graph the relation. Is it easiest to graph the relation if they give it to you as an order pair? Yeah. Is it? Yeah, we could always plot these. You graph it and then you can use this test called vertical line test. What this does, and I'll show you in a minute, if you have a graph, you can tell right away whether or not you have a function or not a function. Marilyn, what do you think this vertical line test is? I think that's what you were trying to tell me before. There's a vertical line? What do you mean?
But that means that the vertical line is on like the x-axis, so it means that if like
Vertical line looks like an x-axis, you're right.
yeah, so if they're on the same line, and that means they're the same point.
Good. Right. So people have a bit of trouble explaining what this is, but I think a lot of you have the idea. You want me to does anybody want to try to look at the 2 different examples? Here, example 2. Can you draw a vertical line so that it hits the graph more than once? On example 2b. Can you draw any vertical line on this graph so that it hits the order pairs more than once? What about the other one?
Yes.
Guess what? If it hits more than once, it is not a function. So here, this is how we say, write this down. A vertical line test. Relation, any set order pair, is a function if and only if no vertical line intersects its graph more than once. Simple as that. Okay. So if you see a graph, right? Or if you don't have a graph, you could graph it, right? You could plot these. If you could draw a vertical line anywhere, if it hits it more than once, not a function, because if it did, then it would mean that it will have more than one output. Does that make sense? So write this down. So now I'm going to give you some graphs, okay? And you're going to decide whether or not we have a function or not a function using this vertical line test. It should just take you like a second, seriously, okay? So here is a graph. Oops, there. Is this a function? By the way, how many order pairs do you see? Infinitely many, right? Okay. Well, maybe it'll take more than a second. I thought it was. Okay, so take a look. Everybody, as a group now. Okay, as a group. First of all, guys, hold on. Do I have a bunch of order pairs? Yeah. Isn't this how a curve? This time it's a curve. Isn't that how this curve is made up? Bunch of order pairs, right? Really closely next to each other. Okay, go ahead as a group. I'll give you time. Think about whether or not it's not a function or a function. Using the vertical line test. So think about it. Can you draw a vertical line so that it hits the graph more than once? Okay. With thumbs up and down. Here. Thumb up for function, thumb down for relation. Halfway if you're not sure. Okay, show me. Function or not a function? Okay. What do you think, Christine? This is for function, this is not a function. Thumb up for function. Sabrina, what do you think? I mean, yeah. Savannah? Yeah, it is a function, guys. Can you draw a vertical line anywhere so that you hit it more than once? No. Oh, what about this? Here, it hits it many times. Is that a vertical line? No, please don't think that. Okay, it's not a vertical line. You could draw any vertical lines. You could draw vertical lines anywhere. There's no way you're gonna hit it more than once, right? Does that make sense? Do you guys understand? Questions? Holland, you look like you have a question. Okay, hold on. Let's listen to this. Yeah. So say it again. Oh, how can you hit it more than? Okay, here we go. So this is a function. Yes, question.
What if you draw? Whatever.
Are you sure?
Cause like.
Yeah, go ahead.
Did you say that it's not a function if you draw vertical lines, right?
No, I said.
Not horizontal.
What? Okay, here, hold on. Okay, I said a relation or any set of order pairs or any graph, right? That's a set of order pairs, right? Anais? Is a function if and only if no vertical lines intersects the graph more than once. So if you draw a vertical line, if it hits it more than once, then it's not a function. So can you draw a vertical line here so that it hits the graph more than once? No. One vertical line. It could be any vertical line, but can you draw a vertical line anywhere so it'll hit it once? No. Not horizontal. I didn't say horizontal line test. It's a vertical line test. Okay. What about this? Nice circle. Okay. It should take you just 1 second. Well, no, don't say it out loud, please. With your hand, thumbs up for function, thumb down for, okay? This is, some of you are not so sure. This is what? Not a function. Look, here, I could draw a vertical line right here. How many times does it hit? So it's not a function, right? I could draw one right here if you want, okay? What about right here? Is that a good idea? No, I mean, I could draw it there, but there are other places where it'll hit it more than once, right? It's not a function. Everybody okay? This is not a function. Okay. All right, may I move on? What about this, guys? This time, I have 2 line segments and a point. Go ahead, think about this as a group. Okay, I'm gonna give you a couple seconds this time. As a group, think about it. Decide whether or not you, okay, ask your group. Well, some of you already know. No, I'm not. No. Okay, I can make it here, bigger. All right. Anybody? So there's a point. Be careful. Okay. How many people think it's a function? Thumbs up. How many people think it's a not a function? Thumbs down. Aaron, why do you say I'm trying to trick you? Go ahead. The dot. Is this a function or not a function, Aaron? It's not a function. Why not, Kyle? Shh. Kyle, why not?
Because you can draw a line through the dot.
That's right.
Straight down and
Yeah. If I was to, now, anywhere else is fine. I could draw a vertical line anywhere else except one place. So does it matter if you can find just one place? If it works for everywhere else, but if it doesn't work on one place, is it still not a function? Yeah, it's not still not a function. Okay, so it's not a function. Okay? Do you guys understand? What if I remove that dot? Then would it be a function? Yes. If I didn't have that dot, it will be a function. Be careful, okay? All right, so how about this? This time, I gave it to you as an order pair. You see how it's easier to have it as a graph than order pairs? But it's not that bad. Go ahead, everybody think, as a group, is this set, does it represent a function or not a function? Go ahead, everybody think about it. Sophia, what did your group come up with? It's not a function. How many people say it's not a function? Raise your hand. Matthew, why not?
Because there are 3 5s. I mean, for the input 5.
Good, that's how you say it. For the input of 5, how many?
There's 3 of them.
There are 3 outputs, you're right. Okay, any questions? So it's not a function, right? 5 has 0, it goes out to 0, 1, 2, right? There are 3 outputs for one input. It's not a function, is it? Now, on your homework or test, if I ask you to list the domain, what would you write down? How about Christine? What would you write down if I ask you to list the domain? For this example 7? 5 and 0 is your domain. You're correct. So you would use the brace, right, to write. What about range? What would you write down as your range? How about Caroline? Correct. 0, 1, 2, 4 is correct. Is this easy?
Yeah.
Okay, let me get a little bit more interesting here and be creative. True or false? Tell me whether this is true or false. All lines are functions. Is this statement true or false? Use your hand for your thumbs up for true, thumbs down for false. Anyone have true? Kyle?
false.
Oh, you did. Oh, wow. Yeah, don't do that. Okay, okay, that's dumb. Okay. Okay. All right, stop that. Okay, that kind of hurts. Kyle, okay, you don't. Okay, so why is this false, Kyle?
Because some lines be like a circle.
That's not a line. Circle is not. Circle is a curve. Oh, that's not the reason. Okay.
Some lines to be like squiggly out.
No, squiggly lines. It's not a line. It's a curve. Like I said, all the lines must be straight, Kyle. So, okay. So that's not the reason. So lines must be straight, guys. If it's not straight, then it's not a line. It's a curve. All right. How about Chansu? That's correct. It's because of the what? Vertical line. Does vertical line pass vertical line test? Of course not. Right? Right? If you were to draw a vertical line on vertical line, right? How many outputs would it have? Infinitely many. That's what. Does that make sense, guys? Guys, this is important because tomorrow, listen, tomorrow's lesson is you're going to have to know this, right? Because you have to understand that all lines are function except vertical lines. Okay.
Oh yeah.
Okay, what about example 9? Go ahead, everybody. Yeah, now this time I got a bit more creative. I actually, instead of order pairs or graphs, a bunch of points, I have given you an equation. What kind of equation is this? Who remembers? Raise your hand. Raise your hand. What kind of equation is this? Yes? It's in standard form of what kind of equation? You're right. It's a standard form of what? Yes? This is not a slope-intercept form. It's a standard form of what kind of equation? Yes? No. What kind of equation? Yes? There's no order pair equation. Yeah. What do you? Yeah, Tali? No, this is not. This is a standard form. Y-intercept form is y equals mx plus b. Lindsay. Thank you. It's a standard form of a linear equation. Why do we call it a linear equation? Because you get a line when you graph. So, think about it as a group. Does this line represent a function or not a function? Go ahead, everybody think about it. So a lot of you are thinking about this. Let me ask you this. Since it's a linear equation, what does this line look like? First of all, what would you do to see what this line looks like? Yeah, Matthew, what would you do? Yeah, you would want to change into slope-intercept form by subtracting x, then dividing by 3. So you would get this. You know that the slope is negative 2/3 and y-intercept is at 2. So does this help you to decide whether or not this is a function or not a function? Well, I can even graph it for you here. Do we not know how to graph this equation? Malia, what do you think? Is this a function or not a function? It's a function. Why, Malia? Each input has only one output because it passes the vertical line test, right? Right? Because is there any vertical line you could draw where you hit it more than once? Not only that, what did we just talk about? Every line is a what? Yeah, every line is a function except for a vertical line, right? So this is a line that happens not to be a vertical line, right? So this is a function. Anais, question.
Okay, I have a question. Is it only when like you have the equation like x equals something is when it's not a function?
We'll get there in a minute. You read my mind. Anais and everybody else, go ahead. I have 2 examples for 10a and 10b. So can you decide when I have y equals to 3, of course on the x and y axis, okay, on both of them. Y equals 3 and x equals negative 3. Which one are these functions or not a function? Go ahead, everybody decide. Okay, for 10a, how many people think that 10a is a function? Thumbs up for function, thumbs down for not a function. You are correct. It is a function because what kind of line is this, class? Thank you. It's a horizontal line. Now, if you don't believe me, I could actually do a little table, right? Remember, I told you, whenever you have, listen, whenever you're graphing these equations, when one of the variables is missing, okay? Right, Tanner? Cameron? Okay. So you know that y is always 3. You could have any axis you want. You get a horizontal line. Draw any vertical line. You don't only hit it once, correct? Of course, then 10b, how many people think it's a function? Put your thumbs up. How many people think it's not a function? Thumbs down. You're right. It's not a function because what kind of lines do you get? Correct. If you don't believe me, you could graph it using tables again, right? Get a vertical line, right? You could draw a vertical line on this vertical line. It's going to hit it more than once, obviously. Does that make sense? Is this easy or hard? Good.